Okay, let's take a look at this example to illustrate the use of ratio theorem. Okay, by now we should be quite familiar with this idea of position vector. P and Q has these two position vector. Now G is a point on the line segment PQ. On the line segment, usually what I would do is then I will draw P here, Q here. Then what we are saying is G is somewhere in between here. Okay, you're about to use ratio theorem to find the position vector of G. Basically, position of vector of G is just OG. Now, if you recall ratio theorem, we should be able to use ratio theorem to find OG. How? All right. If you see here, earlier we have learned ratio theorem, and if I apply specifically here, okay, this is the way to find OG. Now, OP is known, OQ is known because you do know these two, right? You do know these two. What is mu and what is lambda? We can quite easily find out. How? You see here, this line will give you an idea. PQ equals to 3 times of PG. So if you see this, PQ is 3 units, all right, 3 times of PG. So if I were to very quickly fill it up, that means this must be 1 unit, this must be 2 units, which means this lambda is 1 unit, this mu is 2 units. Only then can our PQ be 3 times of PG. Does it make sense? All right, so I'll show you the solution right now. Not difficult. Okay, therefore you use your ratio theorem like that. Okay, look here. I'm applying this one here. All right, your mu is 2. Your lambda is 1. Here like that. This calculation shouldn't be too difficult. Okay, that's the use of ratio theorem. And I really want all of us to be familiar to know how to use the ratio theorem, because the next example will maybe a little bit more difficult.